everyone, welcome to Miss Logically. This video is the next part of prime number video. Okay, so in the previous part, we saw how to check whether a number is prime number or not. We did solve it with for loop and some basic conditions. So in this part, we will be solving it with while loop and we will be optimizing the previous solution a bit as well. Okay, so the link for the first part should be on top of this video somewhere around here. Okay, so go check that first part first and then the next part is here. So let's get started with the today's video. In previous part we had this program where we have a number, and on that number we are running a loop to check whether the elements or the number before that number, any of the number is not dividing our desired number. It means it is not returning remainder as 0 if divisible by any other number. Okay, so this was the program. Just let's run for it for a sec. Yes, it is running. So we used a for loop to do this. We will be optimizing this condition a bit in this video. So as you can see, it is starting with 2. That is fine. The start range is fine. If you look at the number 38, so if we try to divide 38 by any other number, so the maximum divider will be 19, right? And this is the case. Any number which is greater than 19 will not be dividing 38 at all in any case. You took any number, let's say 50. 50 by 2 is equal to 25. So any number which is greater than 25 will not be dividing 50 at any cost. So as you observe the pattern, it is a number by 2 is the greatest divisor of that number. So we will be modifying the end range as a by 2. Let's check if it runs correctly. Not a prime number. Yes, and 37 should be a prime number. Yes, a prime number. Correct. Okay, it is working. Let's try one more number, 4. As you can see, the condition will go from 2 to a by 2 is 2. It means 2 basically, right? Yes, not a prime number. It is working. Now let's start the next part, which is a while loop. So we will be solving the same program, but we'll replace for with while. Okay. So I'm having a loop while where, as you see in previous case, we were determining whether I is dividing a. Okay, I is the increment pointer in the last case. So I'm having the same variable here where I, which starts with 2. Okay, and will span till a by 2. It is the same condition we had in for. Okay, just the format is different, just the syntax is different to write it in a while loop. I'll be checking if a mod I is equal to 0, println not a prime number, break the loop, and also flag is set to false. And same with the previous approach. If is prime, then print as a prime number. Let's check if it is correct. Not a prime number. 4 is not a prime number. What did it say? Is never returned to the included as well. Yes, because we have not incremented it. Okay, so it will not be working for any other number. As you can see, it has gone into infinite loop. Okay, so we have to increment it. Yes, we have to increment the I as I plus plus. Not a prime number because it is divisible by 5 and so on. Okay, so as we are updating the flag here, we can have print statement all the way outside as well. If it is prime, print as prime, else print as not prime. Not a prime number. 11 is a prime number. See, okay, so it should return as a prime number. Yes, so it is working. So this was the second approach to solve the prime number program. Again, in this video, we saw how to use a while loop in a Kotlin. Okay, prime number logic is very well known, and if you can optimize it even more, do let me know in the comments. Okay, so I will meet you soon in the next video. Till then, keep coding. Bye.